Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 981. Please turn to it. Page 981, and today is our lesson number 150. Today is our very last day of this project that we began almost 10 weeks ago. Day number 1 when we started here was on September 29th, 2012, and today as I speak is December 13th, 2012. So as I said, it's been about 10 weeks. 10 weeks ago when I started this project, I told you that we're going to solve every single math problems in this book that I showed you. The book has 10 exams and we have done every single math problems out of those 10 exams except the 2 that we're about to do. So we are finally here at our destination. Let's take a look at it. Number 15 and 16. I'm going to begin with number 16 first because number 16 is a tricky one. It's an algebra problem. Let's see what we can do here. It says, to celebrate a colleague's graduation, M workers in the office agreed to contribute equally to a catered lunch that costs a total of $Y. So we have M workers. M agreed to pay $Y in equal amounts. I'm not going to bother writing it here. M workers. Then they go on to tell us that if P of the workers refuse to pay, if the P of the workers fail to contribute, as they put it, P refuse to pay. If P of the workers fail to contribute, which of the following will represent the additional amount that each of the remaining workers will have to contribute to pay for the lunch? As we can see, it's an algebra problem. And if you've been watching all the other math videos that I have made over the last 10 exams, you know that we have come across many of these algebra word problems. And as I always remind you, when we get to the algebra word problem in the exam, there are 2 ways you can tackle it, or tackle them to be more precise. One is to actually solve a given algebra problem in the manner that they expect you to solve, which is to solve it in the algebraic way, the traditional way, the classical way, the orthodox way, the geeky way, the nerdy way, the academic way, the proper ways, if you will. And the other method that we always do is the quick and dirty way, which is where you simply make up numbers for the variables. Make up numbers for the variables, plug in values for the variables, and thereby we convert a fairly complicated algebraic problem, into a very simple arithmetic problem. And that's what we're going to do here. Let's do it. So M workers agreed to pay $Y. Let's make up numbers for these variables. Now in theory, of course, we can plug in any numbers that we want, as I always remind you. But in practice, it's always a good idea to plug in numbers that make your arithmetic simpler. That makes your calculation simpler. That's the whole idea. So let's pretend that they agreed to pay $400 to the caterer for this lunch. And let's pretend that there are 95 workers. Now as you can see, that will not be a smart idea. Why? Because you can divide 400 into 95 very easily. It will be a hell, it will be a waste of time. So don't plug in 95. Plug in some nice round number that makes your arithmetic simple. Let's pretend there are 100 people. So $400 to be paid by 100 people. Well, that's very straightforward. That comes out to be $4 each. $4 each. It couldn't be any simpler than that. Now let's pretend now that few of them refuse to pay. Let's pretend that 5 of the workers refuse to pay their share. Now let's see what happens. If 5 of the workers refuse to pay, now we have to split $400 among the remaining workers. If we started out with 100 and 5 refuse to pay, the $400 will have to be split among 95 people. We are back to where we started. We don't want 95. We can't divide 400 into 95. Don't plug in 95. Don't plug in 5. Let's pretend it's 10. If you pretend that 10 of them refuse to pay, then instead of 95, we will have 90. I still don't like it. I don't want to divide 400 into 90. It doesn't divide evenly. It doesn't divide nicely. Let's pretend 20 workers refuse to pay. You see, you can play with your numbers until things work out nicely. Let's pretend 20 of them refuse to pay, which means this $400 now has to be split among 80 workers. You divide top and bottom by 10, that goes out, and 40 divided by 8 is just $5 each. So now, as a result of 20 workers' refusal to pay for their share, it turns out the remaining 80 workers will have to pay $5 each instead of $4 each, which they had originally hoped for. Question simply is, how much additional amount that each worker will have to pay? The answer is $1. The answer is $1. $1 is our punchline. $1 is our punchline. All we have to do now is to go through the answer choices one by one. Wherever we see M, we're going to replace it with 100. Wherever we see P, we're going to replace it with 20. Wherever we see Y, we're going to replace it with 400. Until what happens? Until we find the punchline. That's all. Let's do it. Let's do it. Answer choice A. A says Y over M. Y is 400. M is 100. That's not going to give us 1, obviously. We're looking for a punchline is 1. That's not 1. B says Y over M minus B. Well, Y is 400 and M minus B, I don't know what it is, but it's not 400. It's not going to work out to be 400. Had it been a real exam, I wouldn't waste my time here because I know it's not going to work out to be 1. For it to work out to be 1, the bottom has to equal to the top. M minus P is not going to be 400. I know for a fact. M is 100 and P is 20. So as you can see, 400 divided by 80 is not 1. Answer is not B. Let's move on then. C says P times Y over M minus P. Again, I know, I can tell by looking at it that P times Y does not equal M minus P. It's not going to work out to be 1. P times Y, P is 20 times Y, which is 400. That's 400 over M, which is 100 minus P, which is 20. As you can see, it doesn't work out. 20 times 400 divided by 80 does not equal 1. The answer is not C. Let's move on then. D says Y times M minus P over M. Y times Y is 400 times M minus P. M is 100 minus P, which is 20 over M 100. Again, as you can see clearly, these are not the same amount. The top is 400 times 80. 400 times 80 over 100 is not going to be 1. The answer is not D. Let's look at E. Let's look at E because the suspense is killing me. P over Y over P times Y over M times M minus P. P times Y. P is 20. 20 times Y, which is 400, over M, which is 100, times M minus P. M is 100 minus P, which is 20. And let's see what that works out to be, shall we? So this 400 is going to go out with this 100, so that becomes 4, and 100 minus 20 is 80. There you go, you see 100 minus 20 is 80. So on the top we have 20 times 4 over 100 minus 20, which is 80. And there you go, 80 over 80, which is 1. The answer is E. That's it, we're done. The answer is E. So this is one way of doing it. Another way actually is to do it in the classical way, the algebraic way. And if you insist on it, if you're hell-bent on it, we'll do the algebraic way also, just to satisfy your curiosity. Alright, so let's do the algebraic way now, the proper way now. I'll give you a second in case I need to pause it. There we go. So in the algebraic way, of course, we have no numbers to play with. We have no numbers. We just have to do it the algebraic way, which is straightforward. We had $y to be split among n people. We have $y to be split among n people. So that's their share of each person. All of a sudden, the same $y now has to be split among fewer people because P of them refuse to pay. Well, if P of them refuse to pay, then the same Y dollar has to be split among M minus P people. The question is, they're asking us how much additional amount which each worker will end up paying. In order for us to find that, we have to recognize which one is the larger quantity. This is the larger quantity because the denominator is smaller. So it's going to be this minus that. So it's going to be Y over M minus P minus Y over M minus P minus Y over M. This is the answer. All we have to do now is simplify it. When you simplify it until it takes the form that is same as one of the answer choices. Let's do it on the top. The common denominator here is going to be M times M minus P, and here it's going to be Y times M minus Y times M minus P. That's it. Open the parenthesis. So we get Y times M, so we get Ym minus Y times M, and a negative becomes positive, Y times P over M times M minus P. As you can see, this Y times M will cancel out with this one, and we end up with Y times P over M times M minus P. Same as the answer choice E. So that was the classical way, the algebraic way. But like I said, it's not necessary in the exam. If you do it the algebraic way, you're going to end up making some silly mistakes, some predictable mistake. And that's the problem with it. If you end up making one of the 4 most popular mistakes, then the answer that you will arrive at is going to be one of the answer choices that they give you. And you will never know that you made a mistake. So don't do it the algebraic way. Just plug in numbers. So convert this algebra problem into a simple arithmetic problem. And that's it. Very simple arithmetic problem, because now after plugging in numbers, all of a sudden this fairly complicated algebra problem, all it says is that if it costs $400 to cater a lunch, and if 400 people agreed to pay for it, I hope those were the numbers we plugged in, or 100 people rather, if 100 people agreed to pay for it, well then each will have to pay $4. All of a sudden 20 of those 100 people refuse to pay, now we got 80 people who will have to cover the $400. So therefore 400 divided by 80 is $5. All of a sudden, instead of $4, each of those remaining 80 workers have to pay $5. The question simply was, how much more will they have to pay? Well, $1 each. That's it, you're done. That's how simple it becomes. All of a sudden, the most difficult problem in a section becomes a very simple arithmetic problem. That's the way to do it. Let's do the next problem, number 15. We are told that n over n minus 1 times 1 over n times n over n plus 1 equals 5 times k. Well, very first thing we notice is that, where's my pointer? For some strange and inexplicable reason, I cannot talk without a pointer in my hand. Which is very weird, because it's not even a pointer, it's a chapstick. There we go. Very first thing we notice is that we have an n on the top and we have the same quantity on the bottom. So they cancel out. So on the top, all we are left with is n. So it's n times n minus 1 times n plus 1. N minus 1 times n plus 1 is same as a minus b times a plus b. Here, your a is n and your b is 1. Your b is 1. A minus b times a plus b we know equals a squared minus b squared. So that's what this boils down to. This boils down to n over n squared minus 1. And that we are told equals 5 over k. 5 over k. And now we're going to play a little dirty trick. We're going to do it the quick and dirty way. We're going to not we're not going to solve this problem the algebraic way, the theoretical way. We're just going to keep it simple, the quick and dirty way. The quick and dirty way is that, listen carefully, listen very carefully. The quick and dirty way is that when we are told that this particular fraction equals this particular fraction, then if you force the numerator of one fraction to be equal to the numerator of the other fraction, if you force them to be equal, then in that case, the denominator of the first fraction would have to be equal to the denominator of the second fraction. It would have to be. One more time. For example, here, I'm going to erase this part, we don't need it. For example, here we have n over n squared minus 1 equals 5 over k. If we force the n to be equal to 5, if we force it to be equal to 5, then n squared minus 1 would have to equal k. But then, if n is equal to 5, then n squared minus 1 will simply be 5 squared minus 1, which is just 24, and that's your k right there. We're done. That's it, we're done. Finished. It was a pleasant journey. I hope you got something out of it. If you need to work on your vocabulary, as I always remind you, the vocabulary videos are right on my channel. Just look for them. That will help you improve your vocabulary. It will help you get a better score in the reading part. If you're interested in getting a better score in the writing portion of the exam, as I always remind you, as I always pointed out to you, the writing portion of the SAT, the so-called writing portion of the SAT, 80% of the score in that part of the exam has absolutely nothing to do with actual writing, which is the essay, which only constitute 20% of your score. The remaining 80% of the writing portion of the exam is made up of simple multiple choice grammar questions. If you need help with those multiple choice grammar questions, you will find those also at my channel. Just look for them. That will help you get a better score in the writing portion of the exam. The reading portion of the exam, way to get a better score in the reading portion is to work on your vocabulary. You will find the help with that at my channel. And here, the idea is very simple. You must do all the math problem in this book, all 10 of the exams. The more you practice, the better you will get at it. Do you understand? Good luck to you. Bye now.